Good morning. We're going to talk about graphing with two variables. We're going to start with equations and see how similar they are to inequalities. We'll do them both side by side as we go through these. We talked about equations a little bit last week very briefly, but we'll start today with graphing. Y is equal to 2x minus 4. We know in this problem that our slope m is equal to 2 and our y-intercept b is equal to negative 4. So we can start by graphing those 2 points, or that point and using the slope. So negative 4, I'm going to go down 1, 2, 3, 4 and plot that point right there. That's my y-intercept of negative 4. From here, my slope is 2, which we can think of as 2 over 1. So from this point, negative 4, I go up 1, 2, into the right 1. And here I connect this with a solid line here. I'm just trying to get a better line there. There we go. So that would be the graph of the line. Y is equal to 2x minus 4. Now, as we go to the right, y is greater than 2x minus 4. The numbers are exactly the same. The coefficients are the same. The only thing that is different is our inequality symbol, where we have y is greater than 2x minus 4. So again, we're going to go about plotting the y-intercept 1, 2, 3, 4 in much the same way. We're also going to rise and run up 2 into the right 1 in the same way. Now, where we become different is this line is a dashed line. Because this inequality symbol means that the points on the line are not solutions to the inequality. So the points on the line are not solutions to the inequality. With that being said, we have y is greater than 2x minus 4. We have to shade on this side of the line. This will give us, this is the solution region. The solution region. Y is greater than means we go from this y-intercept and we go up. So that means we shade on this side of the graph. Any ordered pair we pick in this shaded region will work for this inequality. Just in the same way, any point we pick that's not in the shaded region, that is down here, those will not be solutions. They will not work. Y equals negative 2/3 x plus 6. Our y-intercept is 6, so I'm going to go up 1, 2, 3, 4, 5, 6 and plot that point. Slope is negative 2/3. That means I go down 1, 2, and to the right 1, 2, 3. And again, I'll connect those 2 points with a line. And we're set up there. That's how we graph the equation of the line. Now we go over to the inequality. Again, 1, 2, 3, 4, 5, 6. My y-intercept is still 6. My slope is still negative 2/3. So I go down 1, 2, and to the right 1, 2, 3. Now, this is less than or equal to. So that means that the points on the line are a solution. So we will connect these dots with a solid line, just like we did in the equation. Then from here, y is less than or equal to. So if I start at my y-intercept, y is less than or equal to when we go down. So that means we would shade on this side of our line, and any point in that region is a solution. Some graphing inequalities information. We graph the line the same as an equation. A couple of things to consider. For less than and greater than, you use a dotted line instead of a solid line, while for less than or equal to, or greater than or equal to, we will use a solid line. What that means is the points on the line with less than or equal to, greater than or equal to are solutions, whereas the ones on less than or greater than, those are not solutions. Okay? Now we also have to have a shaded region for our linear inequalities. So we shade based on the inequality symbol. So if we have y is less than, we have y is less than or equal to. You'll shade below the line because y values get lesser as you go down. If we have greater than or equal to, we shade above because the y values get greater as you go up. Now this works for inequalities that are in slope-intercept form, like the couple that we just saw. So that will always work when inequalities are in slope-intercept form. Now, we have a couple that are not in slope-intercept form. So we look at the equation 2x minus 5 equals 10. So what we do is we calculate the intercepts. We make y 0, and we get 2x equals 10. I get x equals 5 as my x-intercept. I make x 0. I get negative 5y equals 10. I get y equals negative 2 as my intercept. So we plot those points. My x-intercept is 5. 1, 2, 3, 4, 5. My y-intercept is negative 2, down 1, 2. And again, we'll connect these with a solid line because they're an equation. I forgot to switch the inequality symbol there. So let me make that greater than or equal to in our inequality there. But we take a look at the equation. We're good to go there. Now, could you get this in the slope-intercept form? Yes, that is always an option. But sometimes it's just easier to cover up one of the terms, get the intercepts, and connect those 2 points. But 1, 2, 3, 4, 5, our intercepts are still the same over here. Since we changed this to greater than or equal to, we will have a solid line. So we'll connect that with a solid line. Now, we can't necessarily go by the inequality symbol here. We have to test the point. And the easiest point to test is 0, 0. Because what that does is when you substitute 0, 0 in on the left side here, I get 0 is greater than or equal to 10. Is that true or false? Well, hopefully we all know that that is false. So what that means is 0, 0 is not a solution. If 0, 0 is not a solution, that means it cannot be in the shaded area. So that means we would have to shade on the line, side of the line opposite of 0, 0 for this particular example. Again, if it's true, had it been true, we would have shaded towards 0, 0. But since it was false, it's not a solution. We have to shade away from it. And I think this is our last set of examples. We do the same thing. We calculate our intercepts. So I make y 0. I get 4x equals 8. That ends up x equals 2. And I also have 2y equals 8. I get y equals 4. So we have those points, 1, 2, 3, 4, 1, 2. Connect those two. There's our line. Okay, so our line, as we go over here, we're going to have the same intercepts for our inequality, 1, 2, 3, 4, 1, 2. However, with this one, we need a dotted line because of our inequality symbol. So we'll come down here with a dotted line that goes through there. Again, we're in standard form this time, so we need to test the point. And again, 0, 0 will work out well. It makes the left side here 0. I get 0 is less than 8. Well, that's true. That is true. So that means 0, 0 is a solution. So we need to make sure 0, 0 is in our shaded area by shading on that side of the line. When graphing inequalities that are in standard form, you determine where to shade by doing the following. We test the point 0, 0. If 0, 0 gives a true inequality, you shade toward 0, 0. To the contrary, if 0, 0 gives a false inequality, you shade away from 0, 0. That is in standard form. That's all we have for today. Meredith Palo, there is your conclusion. Have a great evening, everybody.